Okay, let's do a little review for the final. So I'm here in the review for the final exam page. Let's take a look at the list of topics that could show up on your final. Pretty much everything we've covered all semester. So all the stuff to do with limits, particularly limits from a graph. Go back and look at what we did on test one, where I give you a picture and ask for the left hand, the right hand limits. Where's the function continuous? Where's the function differentiable? Remember all that weird stuff about points that are not in the domain? We don't list as discontinuities because they're not even in the domain. We don't care about them. Remember those problems we did with continuity, where we have a piecewise defined function and we want to make the different pieces match using one-sided limits. Again, go back and look at test one, look at the midterm. We're going to look at some of that in a minute. I'm just forewarning you. Using the definition of the derivative, the limit definition of the derivative. I am not going to give that to you. You should know that. And the limit as h goes to zero, all that stuff. You got to know all the rules. You got to know you're going to have a whole bunch of here's a function, take the derivative, and very little partial credit on those. You got to know product rule, quotient rule, chain rule, logarithmic differentiation. Practice that. Everybody forgets about it. Implicit differentiation. Make sure you know how to do that. You're absolutely going to have word problems on related rates and optimization. And we'll talk about some of my favorites in a minute. The extreme value theorem, knowing how to find the locals and the globals on, say, a closed interval, knowing the relationship between position velocity and acceleration. You're absolutely going to have a curve sketching problem where I give you some function and ask for all the stuff. The intervals of increasing and decreasing, the critical points, the points of inflection, the concat the whole thing. Make sure you practice L'Hopital's rule. You have totally forgotten about linearization and differentials. And then all the test four stuff, just doing some basic antiderivatives, doing some indefinite and definite integrals, maybe from a picture, maybe from a function. Area between curves is not on the exam. I should take that out of this list. You have totally forgotten about mean value theorem and squeeze theorem. Make sure you refresh yourself on those. Okay, now let's look at some actual concrete examples. So here is an old exam. Okay, so limits from a graph. One-sided limits. Where's the function discontinuous? Where is it not differentiable? Just finding some derivatives. Here's one where I have to use logarithmic differentiation. If you have your variable raised to a variable, you're going to have to use logarithmic differentiation. Remember, when you're doing antiderivatives, don't forget the plus c. We're using implicit differentiation. We're finding equations of tangent lines. Practice those. Definition of the derivative here. Remember, like I'm a stickler how I want these written up. You got to have limit as h goes to zero at every step until you actually take the limit. Knowing the relationship between position, velocity, and acceleration, knowing how to graph those. Oh, look, it's the lifeguard problem. Well, there are a bunch of different optimization problems we have practiced. This is definitely one of my favorite. We'll look at some of the others in a minute, but make sure you know how to do all my favorites. Finding locals and globals on an interval. Don't forget to check the endpoints. Endpoints can be globals, but they're not allowed to be locals. Integration by substitution. Absolutely practice these. Be very careful with your limits. Doing an integral based on a picture. Understanding that an integral is just the area under a curve with the assumption that anything that's below the curve is negative area. Oh, look, it's differentials. We've got the whole worksheet on differentials we can look at. Don't forget units. Any word problem, you're going to have units. Oh, look, it's a related rates problem. It's the ladder problem. We've done this problem a bunch of times. Practice those. A bunch of L'Hopital's problems. Linearization. You guys always forget how to do linearization. Go back and rewatch the lecture videos on linearization. That's what I would recommend. And then try some from the extra worksheet. This will not be on your exam. You don't have to worry about area between curves. Oh, look, it's curve sketching. That's one of my favorite topics. All right, what else do we have in here? Oh, look, a whole bunch of old practice tests. Here's another old practice final that has solutions. All of these are good. But then, look, here's a bunch of extra optimization problems that you can work. And I have all the solutions here. Here's a bunch of extra L'Hopital's, bunch of extra linearization. I've got all these extra worksheets in here. If you can do every problem that exists here in this page, you're going to do great on the final. So here, maybe let's take a look at some of the linearization problems. Yeah, these are all good problems. Good differentials problems. Okay, I think that's a good place to stop.